In this problem, we need to resolve the given rational fraction into partial fractions. So let's begin. Now, we have 5 factors in the denominator. That's because the factor x is repeating 4 times, and we have another factor x plus 1. So that means we can split the given rational fraction, which is 1 over x raised to the power of 4 multiplied to x plus 1 into 4 partial fractions. So our first partial fraction will be a over x. So we're considering the one of the factors. Then the second partial fraction will be b over x squared. The third partial fraction will be c over x cubed. And the fourth partial fraction is going to be d over x raised to the power 4. So this takes care of all the 4 factors of x, that means of x. Now we are left with another one more, so that's going to be e over x plus 1. So we have split our given rational fraction into 5 partial fractions, and our goal will be to obtain the value of a, b, c, d, and e. So let's do that. We are going to label this as equation number 1. Now here there is a method known as the cover-up method. Using cover-up method, we can find out the value of the constant d and e. So let's check that out, how it can be obtained. Now we'll start by first obtaining the value of the constant d. All we have to do is write the original rational fraction, but instead of but here we'll have to cover up the factor x raised to the power of 4. That is the denominator of d over x raised to the power of 4, which leaves us with 1 over x plus 1. So this is how we can obtain the value of d. We have covered up x raised to the power of 4. Covering up x raised to the power of 4 means we have to equate x raised to the power of 4 to 0. Solving for x, we get x equals to 0. So if we substitute x equals to 0 into this equation, this is going to give us a value of d. That means we are going to have 1 over 0 plus 1. So that's equals to 1. So this is the value of d. Now we can find out the value of e as well. So using the cover-up method, now we're going to have 1 over x raised to the power of 4. This is the original rational fraction, but we have covered up the factor x plus 1 in the denominator. Since we've covered up x plus 1, this means that we will have to equate x plus 1 to 0, and this gives us a value x equals to negative 1. So we are going to substitute x with negative 1 into this particular rational fraction. So we're going to get 1 over negative 1 whole raised to the power of 4. So this is going to give us a value 1. Now we're still left with the constants a, b, and c. How do we find out that value? Okay, let's do that. What we'll do, we'll take equation number 1 and multiply it with the denominator of the original rational fraction, which is x raised to the power of 4 times x plus 1. And this is going to give us, we have 1 on the left hand side. On the right hand side, we're going to have x cubed times x plus 1 multiplied to a. This is going to be the first term, followed by x squared times x plus 1 multiplied to b. Then the third term is going to be x times x plus 1 multiplied to c. Then the fourth term is going to be x plus 1 times d. And the fifth and the final term is going to be x raised to the power of 4 times e. We're going to label this as equation number 2. We have already found out the value of d and e. Now we'll have our task is to find out the value of a, b, and c. Now clearly equation number 2, that's an identity in x. So here we have to take few values of x. So let's say we take x equals to 2. So if we take x equals to 2, we have to choose the value of x in such a way that x cannot be equals to 0 or negative 1. We can take any other value. We have already used those values. So let's say if we start by taking x equals to 2 and substitute into this following equation, then we're going to get that we're going to get. And also we're going to use the d equals to 1 and e value equals to 1 as well. So this is going to give us 24a plus 12b plus 6c equals to negative 18. Let's label this as equation number 3. Then we are going to take another value of x. So we're going to consider x to be equals to, let's say, 3. So if we take x equals to 3, including d and e value equals to 1, we're going to get the other equation, which is 108 times a plus 36b plus 12c So that will be equals to negative 84. We're going to consider it as equation number 4. And we're going to take one more value for x. So let's take x equals to 4 with d value equals to 1 and e value equals to 1, which gives us another new equation, which will be 16a plus 4b plus c equals to negative 13. That does be equation number 5. The whole reason behind it, why we took 3 separate values of x, because now we have 3 equations, and because we have 3 unknowns a, b and c. So this is a simultaneous linear equation of 3 variables. So using standard methods, which I'm leaving as an exercise for you to try out. So we get 3 values for a. So we get a equals to negative 1, b value will be equals to positive 1, and c value will be negative 1. So these are the 3 values. So we also have obtained the value of d as well. So let's note it down. So d was 1 and e was 1. I'm writing it down because we can now finally substitute this back into equation number 1 to get the required result. So let's do that. Therefore, the final value, we have 1 over x raised to the power of 4 multiplied to x plus 1. So this will become negative 1 over x plus b value is 1. So we have positive 1 over x squared. C value is negative 1. With negative 1 over x cubed plus d value is 1. So 1 over x raised to the power of 4 plus e, which is 1, divided by x plus 1. So this is going to be the required partial fractions of the original rational fractions.